All right, it's IoT with Robert Welborn. Robert, thank you so much for your
Thank you, Seth.
time, as always.
Good to be here.
So, we did the myths. It's now time for the truths.
Yeah, it is time. I mean, I guess it's time to switch from what we all thought we believed to what we're terrified to believe. So yeah.
Fair enough. All right. So, the first truth, as you have told me, is that autonomous works best actually in challenging environments. I would think, no, 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 give me this plastic, straight grid path, leave me alone. That's what I want. No, no, no.
And it's really interesting, and I guess I'd describe it like I think the easiest way to do this experiment is try using your cruise control on a busy street in traffic versus using your cruise control on a highway. And cruise control doesn't learn unless you have adaptive cruise control, which is available on 27 Chevy GM models, Chevy, GMC, and Buick,
Fantastic
and
plug,
of
by the
course Cadillac, available on all of our Cadillac models.
way. Even better
But
plug.
yeah, thank you. Um, But the point here being that the adaptive cruise control, where it basically has radar and it's sensing how close you are to somebody else, it works pretty well in congestion. It works very well, I think, in congestion. But even then, it's still a little bit more nerve-wracking to turn that over to the car. If you've used a traditional cruise control, the one that you kind of set it to 45 miles an hour and just drive, um, you know, busy highway, that's a terrifying prospect because you're hitting brakes, turning it on, turning it off over and over again. And basically, if you're on an oval, if you're on a racetrack, and you set the car to 75 miles an hour, you're going to be turning left, but outside of that, it's that's it. You're good. Um,
So,
and
if the car could learn, how could it learn in
Yeah,
that
there's
environment?
just nothing for it to interact with.
Mhm.
And so one of the things that you'll see is that a tremendous number of the autonomous vehicle companies are working in the spaces like San Francisco and Phoenix, and San Francisco in specific, because they have a very challenging uh, traditional lane environment in their local streets, non-highway.
Not
Um,
to mention the topography.
the topography isn't great. The lanes are sometimes three, sometimes one, sometimes half, with a car parked in the side. All of these things. The parking. There's some streets with no street parking, some streets with all street parking. It's there's a lot of varying, and so. The way that learning works in general, I mean, the way that learning works for math, is that you learn this problem, and then you're able to generalize from that problem. And you see that the teachers teach the kids with there's three apples and three apples, and you put them together and you've got six apples. And the same thing works for toys, and the same thing works for and that's basically the idea that that we pick a problem that we can generalize from.
Mhm.
And frankly, San Francisco streets are a remarkably rich environment for problems that you've never seen before. One of the uh, you know, Somebody crossing at a crosswalk at a stoplight when the light is um, red for you, and the crosswalk light is illuminated. That's the normal situation. Somebody crossing in the middle of the street with a shopping cart that's on fire, that is yelling and waving their arms around. Like, that's something you can generalize from. If you can handle that, you can. It's the New York thing. If you can make it there, you can make it anywhere. And it's a similar situation for highways in Phoenix, and this is not meant to be a judgment call on the good people of Phoenix or even the Arizona uh, highway departments, but they build some very complicated exit ramps and on ramps, and they divide ramps in the middle of the ramp, and then multiple times in the middle of the ramp they have left exits that put you onto the right lane of another highway. So Phoenix happens to be a very progressive city from a traffic management standpoint, but in the in the meantime, what they've become is a really good place to test out new highway technology. And the I'm sorry, Seth. There's somebody else who just joined us on the bottom of the call.
Oh, no, that's only on your
Okay.
screen. Don't worry about it.
Okay.
No one else can see this.
Okay.
So we'll just
Okay.
leave that person alone
Okay.
for a
Just
second
checking.
because
No, well, it's just I didn't want to interrupt.
no, that's fine. I want
Okay.
to interrupt if you don't mind.
Okay.
So we've
Yeah.
got the complex city structure. We've got the
Yeah.
complex kind of highway structure.
Yeah.
And what you're saying to me is rather than our wonderful brothers and sisters in Kansas City where everything is kind of straightforward, we
Yeah.
like
It's a
these
grid.
learning environments which are deeper,
Yeah,
essentially.
that's definitely the case, and I think this has been one of the reasons why you'll hear a lot of folks say it was like, why are you testing this in San Francisco? Why are you testing this in New York? Why aren't you testing this in, here where it's, here in Kansas City, here in Oklahoma City, where real people live, and we would use these cars, and the thing is that it's just not as generalizable. I mean, quite frankly, grid cities, in particularly extremely well designed grid cities, are actually there's less learning to do, and that the complicated stuff, the crazy stuff of a person doing cartwheels in the middle of traffic down the stripe, is going to teach the vehicle how to deal with unexpected phenomena. And the thing is, the vast majority of time, the unexpected phenomena are things that would be a or safety issues. And so if we can make the vehicle learn to recognize things like this and generalize from things like this, like that's really the magic there. And so
And then we
finding,
can come back to Oklahoma City,
yeah,
and everything's going to
absolutely,
be nice and easy.
yeah, and I think that's probably the biggest thing here is that the whole rest of the United States, basically where do we go learn from next is going to be, well, what's slightly less complicated than San Francisco. And New York's a good example. It's interesting. Las Vegas, every year at CES, for the last couple of years, there's a lot of autonomous vehicles going on there. And CES in particular, with the millions of people milling around, and a showgirl crossing behind a guy in a Godzilla costume. These are very good, challenging situations for that are extremely generalizable, because oddly enough, guy in a Godzilla costume is roughly generalizable to a guy crossing the street.
Also, would happen in San Diego around Comic-Con. So,
Yeah, exactly. So I think what you've just described is like that's kind of the wish list. Is I mean, what each one of the AV companies is looking for is finding these places that we can generalize from.
there we go.
Yeah.
All right. So it's not slow and steady and easy first. It's not, low hanging fruit first. It's not, easy POC first. It's no. Let's go to a place that's really weird and
Bring
learn
out the
from that.
freaks. Yeah.
Really weirdly designed is what I should have said.
Exactly. And I don't think weirdly designed is the important thing. It's uniquely designed,
Uniquely.
and because there are places that are just, they're not suitable for driving. I am not going to pick on any particular neighborhood in New York, but there are places in London, for example, that it was not designed for cars to drive in, and cars drive down this. If you've been to Madrid or Toledo, this was donkey was the method that we were planning, and now you're trying to drive a Fiat through it.
There you go.
So that's
And the big Fiat is your
yeah,
point.
not even the small one. Yeah.
Right. Yeah.
So.
Excellent. All right. Fantastic. Complex environments is what we want. That's the first truth. And we've got two more, and I can't wait for them. But in the meantime, I will bid you a fond farewell. Enjoy the days that we have in between now and the next one. Looking
I
forward to it.
can't wait. Okay. Take care.